Hi everyone, and welcome to this next video in our Flash game design series. We're starting to get into some pretty heavy action script, especially if you're a beginner at computer programming. If you're finding it difficult, stay with it, don't give up, keep trying, keep thinking. We'll work it out. So at the moment, this is the game that we've managed to develop. We've got our player paddle moving, and we've got a ball that's bouncing beautifully off each of the 4 edges of the game area. Wonderful. Look at this though. My player paddle, if I move up the screen, half of it disappears. And if I move it down the screen, half of it disappears. I don't really want that to happen, to be honest. I want the player paddle to stop when it should stop, at just on the edge of the game area, so it's not leaving the game area. So do you remember we were already messing around with ball heights and ball widths to make the ball stay beautifully in the game area? I think we need to use a similar technique for the player paddle. So see if you can figure that out, okay? Alright, today in this first half of this 2-part tutorial, we're going to look at how to control the computer paddle. And this was the idea that I had the other day when I was thinking about this. First of all, I'm going to click on my computer paddle. I'm going to find my properties window. Properties. And I'm just going to remind myself what I called the instance of this paddle here. I called it computer. Okay? So I need to know that for my action script. Right, so this was my idea. Computer.y is equal to ball.y. So as the ball is moving up and down the game area, the computer paddle is simply following it on the y-axis. Remember, this is inside the game loop, okay? So if we test this, this is what we see. The computer paddle is following the ball beautifully. And if you were to watch this for 4 or 5 minutes, you would see that the computer paddle never loses. The ball hits the computer paddle every time. And even if I speed up the ball, let's just give it a speed of 6 on the X and Y axis. Even if I speed the ball up, it never loses. I've just created an invincible computer paddle. It's undefeatable. So that's not really the best solution for moving the computer paddle. I'm going to comment that out. So this is the technique that I'm going to use for my game. Let's just get rid of this action script screen for a minute, and I'll try and explain what my thinking is. Just going to make this bigger so it's obvious what I'm talking about. Okay, so this is going to be my computer programming logic for controlling the computer paddle. Whoops. Just going to move this down here. Okay. If the y coordinate value of the ball is less than the y coordinate of the computer paddle, I'm going to move the computer paddle up the screen at a fixed speed. Okay, let's say we're changing the y coordinate value by 3 or something like that. So if the y coordinate value of the ball is less than the computer paddle y coordinate, I'm going to decrease the value of the y coordinate of the computer paddle. I'm decreasing the value of the y coordinate, which means it will be approaching 0. And if the y coordinate of the ball is greater than the y coordinate of the computer paddle, I am going to increase the y value of the computer paddle to move it down the stage towards the ball. So that's my logic for how I'm going to control the computer paddle. Okay? And in ActionScript, this is what I'm going to do. If the y coordinate of the ball is less than the y coordinate of the computer paddle, if that is true, I'm going to change the y coordinate of the computer paddle. Let's do steps of 3. Now, is it plus or minus? If the y-coordinate of the ball is less than, what situation are we thinking about here? If the y-coordinate of the ball is less than, that means the ball is somewhere up here and the paddle is somewhere down here. So in that situation, I'm going to be decreasing the value of the computer paddle's y-coordinate because I want it to move up. So that should be, in this situation, that should be minus. And now let's look at the other situation. If the y-coordinate of the ball is greater than the computer's paddle's y-coordinate, I'm going to increase the value. Computer.y is equal to the current value of the computer paddle's y-coordinate plus 3. Now let's just test that. Brilliant. Okay, so that works. Let's just set the speed of the player paddle and the speed of the computer paddle to be the same. So they're both moving with this kind of change speed of 3. And if we watch this for a few minutes, we will see that the computer paddle always wins. Let's just decrease that. There we go. Now we can see that if we watch this for a few minutes, we can see the computer paddle always wins. So again, we've got a really kind of boring game, really. Maybe not a boring game, but definitely a difficult game. Or maybe an impossible game. But what happens if we change the speed of the ball? We're going to make the ball speed faster than the paddle speed. Remember, the paddle speed, I just made it 3. And I'm going to make the ball speed 6. Let's just count the number of times. So the ball wins there. Oh! And the ball wins. And that time, I think the paddle just got that. Oh, the paddle got that one. That's fine. Fair enough. I think the ball won that one. The ball won that one. The ball won that. Okay. So now the ball is getting past the paddle most of the time. So now the game is too easy. So we need to find a way of not making the ball too slow all the time, but not making the ball too fast all the time. It would be great if the ball speed kind of changed during the game. Sometimes it's slow and sometimes it's fast. And that makes it difficult for the paddle to win all the time or lose all the time. And that's what we're going to be doing in part 2 of this part of our game design series. So just for now, see if you can program your computer paddle as I've done here.